In the winter of 1923, a fire tore through a manufacturing plant in Milwaukee, Wisconsin. By morning, the building was gone. The machinery, the inventory, 5 years of engineering work reduced to ash and twisted iron on a frozen factory floor. The man who built the company walked away from the ruins. He had no capital to rebuild. He was finished. His partner refused to accept that. That partner bought the charred remains at a public auction with almost nothing in his pocket. He reopened the doors and started over with a burned shell of a building, almost no manufacturing capital, and no clear path to what came next. He did not know, standing in those ruins in 1924, that what he was rebuilding would eventually become one of the most trusted names in the professional trades. What he did know was that he was not walking away. This is the story of Milwaukee, the company that almost did not exist. And this is Trades Archive. If you find value in historical deep dives like this one, give this video a like and subscribe for more. To understand what Milwaukee eventually built, you first have to understand what construction work cost the human body before anyone built it. Before 1918, power tools were not designed for the people using them. The portable drills that existed at the time weighed between 25 and 50 pounds. They required 2 hands, a braced body, and upper body strength that accumulated damage across a career. If the bit caught in a piece of steel at the wrong angle, the torque transferred instantly into the operator's wrists. Broken bones, torn ligaments. The tool industry accepted this. The body was an engineering constraint, not a problem to be solved. By 1918, Henry Ford was running the most efficient automobile assembly operation in the world at his Highland Park plant in Detroit. The Model T came off the line at a pace no factory in history had matched. But Ford had identified a bottleneck. His workers spent hours maneuvering heavy, 2-handed drilling equipment to assemble chassis and body panels. The tools were destroying shoulders. The fatigue was slowing the line. In Ford's world, that was a mechanical problem with a mechanical solution, and he needed it solved immediately. Ford reached out to a young manufacturer in Milwaukee, Wisconsin, named A.H. Petersen. His requirement was precise. Build a power drill with 1/4-inch capacity, light enough for a man to operate with one hand all day, without fatiguing. What Ford was asking for did not exist. The prevailing engineering assumption was that you could not strip enough weight from the housing and motor to make a drill one-handed without also stripping out the structural integrity needed to survive professional use. Petersen accepted the commission anyway. He rethought the tool from the inside out. He eliminated cast iron wherever it was not load-bearing. He redesigned the motor housing geometry. He rebuilt the internal gearing to minimize weight without sacrificing output. When the work was finished, the drill weighed 5 pounds. Against an industry standard of 25 to 50, that was not an incremental improvement. It was a different category of object. He called it the hole shooter. Ford's assembly line workers picked it up, ran it for full shifts, and reported back that the fatigue was gone. Production accelerated. On the strength of that single tool, Petersen's company grew quickly into a serious manufacturing operation. Then, everything changed overnight. The winter of 1923. A fire. The kind that starts in the walls, finds the oil-soaked wood of a working factory floor, and does not stop. By the time it was out, the building was burnt to nothing. The machinery warped, the inventory gone. Everything Petersen had built, in a single night, reduced to ash and frozen wreckage on a Milwaukee street. He had no capital to rebuild. He walked away from the ruins. He was done. Albert Siebert was Petersen's partner and chief sales executive. He had watched the hole shooter change how Ford's plant operated. He understood that the tool was not an interesting novelty. It was a fundamental rethinking of what industrial labor could look like when the equipment was built around the body instead of around the machine. He was not willing to let that disappear into the wreckage. In 1924, Siebert bought the burned assets at auction and officially founded the Milwaukee Electric Tool Corporation. The problem he inherited was immediate. He had the concept, the name, and a facility. He had almost no capital to manufacture at volume. He needed cash flow fast enough to keep the lights on while he rebuilt the product. What he did next was one of the quieter acts of strategic intelligence in American manufacturing history. Siebert opened a repair shop. He took in broken tools from any trade customer who walked through the door. He did not limit intake to Milwaukee's own tools. He actively solicited broken equipment from his largest competitors, including Black & Decker and Stanley. He put the word out, "Bring me whatever is broken and I will fix it." Day after day, his engineers disassembled the damaged machines that came in. They worked through failed gearing systems, burnt armatures, cracked housings, and switches that had given out under sustained load. Every failure documented a specific engineering decision that could not survive real-world stress. Siebert cataloged all of it and applied it directly back to the hole shooter. He rebuilt the metallurgy of the internal components. He reinforced the electrical architecture based on exactly where competing tools failed under commercial use. Milwaukee's engineers learned what broke a tool by fixing the competition's broken tools. By the time they had enough capital to manufacture at scale again, the hole shooter was a materially different product from what had burned in 1923. The lineup did not stay at one tool for long. The original hole shooter was a 1/4-inch drill, fast and light, but the construction trades were beginning to demand more capacity. Milwaukee introduced the Super Hole Shooter, a 1/2-inch capacity variant built for heavier drilling in timber framing and structural steel. Where the original was precision and portability, the Super Hole Shooter was sustained torque for applications that would have destroyed a lighter machine. Industrial contractors were anchoring heavy machinery into concrete floors, a task that required hammering force sustained over time that standard rotary drills could not deliver without overheating. Milwaukee built a 3/4-inch electric hammer drill specifically for this, rotation combined with a hammering action that drove masonry bits through concrete without burning out the motor underload. It was heavy by design, built to the same durability standard running through everything else Milwaukee made. The heavy-duty 1/2-inch drill was engineered for continuous commercial use on job sites running multiple shifts. The housing was reinforced. The thermal management inside the motor was improved to handle sustained high-load operation across a full working day. Not a drill for a weekend project, a drill for a professional who needed it to start every morning and finish every evening. And then there was the Whole Hog. The Whole Hog was one of the more extreme products Milwaukee had ever produced. It was a right-angle drill, meaning the motor sat perpendicular to the bit rather than in line with it. The specific problem it solved was rough-in work, the stage of construction where plumbers and electricians drilled large-diameter holes through joists, studs, and blocking inside wall cavities and floor assemblies. A standard drill in a standard 16-inch stud bay had to be angled awkwardly or run in short, fatiguing bursts. The Whole Hog fit flush into the cavity, positioned the bit where the hole needed to be, and drove a 2.5-inch spade bit through doubled dimensional lumber without bogging down. For a plumbing crew rough framing an entire residential development, the Whole Hog changed the math on how many houses they completed in a week. The Whole Hog, in various updated forms, is still in production today. By the time Milwaukee reached the Second World War, the product lineup covered drilling for wood, steel, and concrete across a range of capacities and physical configurations that no competitor had matched. The reputation forming around the brand in the trades was simple and specific. These tools did not break when others did. The war arrived, and it accelerated everything. The United States Armed Forces needed tools to build aircraft, tanks, and naval vessels at a scale the country had never attempted. Shipyard work was the most severe environment, with salt water, freezing temperatures, and continuous heavy load shifts running around the clock. Commercial tools not built for those conditions failed within days. The resulting production halts were unacceptable. The United States Navy issued strict manufacturing specifications for the equipment coming into their yards. Tools had to survive drops from height, sustained moisture exposure, and continuous maximum load operation without failure. These were binding requirements, with no tolerance for compromise. Milwaukee met those specifications. Then Siebert went further. He made a company-wide mandate. From that point forward, every Milwaukee tool was manufactured to the United States Navy's standard, regardless of whether the customer was a shipyard or a residential electrician. The military requirement became the production floor, not a ceiling reserved for government contracts. The phrase "heavy duty" in Milwaukee's product identity came from a military specification that was absorbed into the assembly line and never removed. When the war ended, the United States entered the largest residential construction expansion in its history. Suburbs spread across the country at the same time. Tradesmen doing the rough-in framing for those houses, the plumbers and electricians and carpenters, were running into a physical constraint that had not changed in decades. Running pipe and conduit meant hauling a manual hacksaw back and forth through galvanized steel, cast iron, and dimensional lumber, often in crawl spaces with no room to maneuver. A single cut in a difficult location took 45 minutes. The shoulder damage accumulated across a career, and the pace of the housing boom was outrunning the capacity of the trade crews doing the work. In 1951, Milwaukee released a tool that made the hand hacksaw obsolete overnight. The Sawzall was the world's first portable electric reciprocating saw. The blade moved back and forth rather than rotating, which was the correct motion for cutting through pipe and structural materials in locations where a circular blade could not reach. The mechanism inside relied on only 3 moving parts. That simplicity was the engineering decision that made everything else work. 3 parts meant the violent vibration generated by cutting through iron pipe found almost nothing inside the tool to fatigue or fail. Competing tools that attempted reciprocating motion shook themselves apart under similar loads. The Sawzall kept cutting. The 45-minute handsaw job now took 30 seconds. Adoption across the plumbing and electrical trades was immediate and total. And eventually the Sawzall crossed the threshold that marked genuine category dominance. It became the word. Tradespeople around the world called every reciprocating saw a Sawzall, regardless of what name was stamped on the housing. Through the 1960s, Milwaukee extended the product line in directions the original hole shooter could not have anticipated. The right-angle drill. Plumbers and electricians drilling large-diameter holes through floor joists and wall studs in framed construction needed a tool that fit within the 16-inch spacing between structural members and still generated enough torque to drive a large bore bit through dimensional lumber. The right-angle drill's geometry solved this, with the motor set perpendicular to the bit axis and a tool footprint narrow enough to fit where a standard drill could not reach. The Magnum hole shooter. The corded drilling lineup pushed to its upper performance limit. Where the original hole shooter emphasized precision and portability, the Magnum delivered maximum sustained torque for the heaviest commercial applications, such as thick timber beams, structural steel, and deep concrete anchoring. By the late 1970s, Milwaukee was the default answer for every electrician, plumber, and mechanical contractor who needed wall plug power and did not want to think about whether their drill was going to survive the job site. In the enthusiast and professional forums that would eventually document this era, the phrase for it was simple: you were either running red or you were not running serious. Team Red became the community's own language for what Milwaukee had built. The numbers backed it up. Milwaukee held the dominant position in heavy corded professional tools across every major construction trade. The brand equity was deep enough that the name alone carried weight on a job site. Then the cord got cut, and everything Milwaukee had built started to erode. Makita introduced a 9.6-volt cordless battery system in the early 1980s. The power output was modest compared to what came later, But the proposition was not about power. It was about movement. No one had to drag 100-foot extension cords through mud and scaffolding. No outlet hunting on job sites not yet fully wired. Workers could move freely across the site without managing a cord tethered to the wall. Milwaukee saw it. They did not respond to it. Not seriously. Not with the urgency the moment required. Then DeWalt entered. In the 1990s, DeWalt launched an 18-volt nickel-cadmium battery platform with the most effective market entry the tool industry had seen. The yellow color scheme made the tools identifiable on any job site from 40 feet away. The marketing was direct and sustained. DeWalt put tools into the hands of working contractors and let the performance build the reputation. They did not fight Milwaukee on corded territory. They built a new territory entirely and planted a flag there before Milwaukee had a plan. The 18-volt nickel-cadmium platform became the new professional standard for cordless work. Team Yellow was on every belt and in every truck on active job sites across North America, and for the first time in the company's history, Milwaukee had no answer. This was the moment the decline began. Not with a fire, not with a competitor out-engineering them. It began with ownership that did not understand what it owned. Amstar Corporation acquired Milwaukee Electric Tool and held it without any apparent strategy for the cordless transition. The Swedish industrial conglomerate Atlas Copco acquired it next. Milwaukee did produce cordless tools during this period, but they were heavier than DeWalt's equivalents, and they arrived on the market late. The engineering discipline that had built the hole shooter and the Sawzall was not being applied to the battery platform. The investment was not there. The focus was not there. What the community noticed was that Milwaukee was reacting, not leading. Pro users who had bought red because red meant serious started crossing over to yellow because yellow was delivering what they actually needed on a cordless job site. Every professional buyer who made that switch took a piece of the brand equity with them. Once brand equity started bleeding out, it was very hard to stop. By the early 2000s, the construction trades had sorted Milwaukee into a specific mental category. The heavy, indestructible corded tools your experienced uncle had kept in his garage since 1975. Pro-grade history, not the pro-grade present. DeWalt and Makita owned the professional cordless market. Milwaukee was stuck between them and the box store brands, respected for what it had been, and increasingly invisible in the conversation about what to buy today. In 2005, Tektronix Industries, a holding company based in Hong Kong, acquired Milwaukee Electric Tool from Atlas Copco. Tektronix Industries brought in new executive leadership with a single directive: turn this around. The new team looked at the landscape and reached the conclusion that anyone running the numbers honestly would have reached. Trying to beat DeWalt in the 18-volt NiCad game was not a viable path. DeWalt's distribution was too deep. Their brand recognition in the professional trades was too established. Their retail relationships were too entrenched. Catching up through incremental improvement would produce, at best, a permanent, distant second place. The only viable move was to bypass the existing competition entirely. The technology they chose to bet on was lithium-ion. The engineering community's response to that plan was not encouraging. In 2005, lithium-ion batteries were in consumer electronics, cell phones, laptops, and other low-draw devices where the chemistry performed reliably within its tolerances. The problem with putting that chemistry into a heavy-duty construction tool was thermal runaway. When lithium-ion cells were pushed beyond their thermal limits, they did not simply fail. Under the right conditions, they ruptured or ignited. A hammer drill at full load, a circular saw ripping through dense hardwood, pushed cells very hard and very fast. The heat generated by a construction tool under real professional load was categorically different from the heat a laptop generated sitting on a desk. Engineers who heard Milwaukee's plan said it plainly: the chemistry was not ready for that application. The safety risk was not theoretical. Putting lithium-ion in a heavy-duty power tool was engineering suicide. Milwaukee's engineers did not argue with the risk assessment. They built around it. The first solution was structural proprietary heat dissipation framing inside the battery pack that managed thermal spread across the cells under load. The second solution was the more consequential engineering achievement. Milwaukee developed a microchip communication system that created a continuous real-time data link between the tool, the battery pack, and the charger. The battery's internal temperature was monitored throughout operation. If the cells approached the thermal threshold, the system reduced the power draw before the limit was crossed. If the threshold was breached, the tool shut down automatically. The battery, the charger, and the tool stopped being three separate objects. They became one managed system. In 2005, Milwaukee launched the V28 lithium-ion platform. The performance gap over 18-volt NiCad was not incremental. The V28 delivered approximately twice the runtime at lower overall weight, with no memory effect. NiCad batteries degraded in maximum charge capacity if repeatedly recharged before full depletion. Lithium-ion carried no such limitation. Charge it when convenient. It retained full capacity. DeWalt and Makita had no ready answer. Both companies had lithium-ion programs in development, but Milwaukee was first to market with a product that performed under real professional load. Team Red was back. And this time, they were not catching up. They were ahead. The reversal inside the professional trades community was fast. The forums that had spent the early 2000s writing Milwaukee's obituary were now running runtime comparison threads between the V28 and every 18-volt NiCad platform on the market. The numbers were not close. The company that had been categorized as a legacy brand was now setting the standard. That reversal bought time and credibility. What Milwaukee did with that window determined the next 20 years. The strategic decision that defined the modern era was not technical. It was a question of who they were going to build for. Every major competitor in the tool market pursued the broadest possible customer base. DeWalt, Makita, and Ryobi built product lines ranging from high-end professional equipment down to consumer-grade tools sold at retail for homeowners. The market for weekend warriors was enormous, and the volume numbers were attractive. Extending the product line downward to serve it was a standard industry move. Milwaukee refused to make that move. They defined their customer as the working professional in one of 5 core trades: plumbing, electrical, HVAC, industrial mechanics, and utility line work. They walked away from the consumer-grade market entirely. No tools for homeowners. No SKU diversification into product lines that compromised the professional specification to hit a lower price point. The company was going to build for people whose livelihood depended on whether their tools worked. The practical effect of that focus was that Milwaukee could justify research and development spending that no company chasing the mass consumer market would ever approve. Milwaukee sent engineers to commercial job sites for weeks at a time with one assignment: watch. Watch how an electrician stripped wire in a cramped panel box. Watch how a plumber made a connection in an 18-inch crawl space. Watch where a mechanic's body position limited what their tools could reach. Then go back and build the specific tool that solved the specific problem that observation identified. Build it for a professional who used it every day. Price it accordingly. A $300 tool built for one specific trade application, justified because the professional buying it would use it thousands of times over the next decade. That philosophy produced the M12 and M18 cordless ecosystems. The engineering decision at the center of both platforms was battery architecture. Rather than building separate battery systems for separate tool categories, Milwaukee engineered a single M18 lithium-ion battery pack to power every tool in the professional lineup. One battery, one charger. A contractor bought into the platform once and expanded the tool inventory indefinitely without discarding existing battery stock when a new tool was added. Platform loyalty, in the community's language for it, became a genuine structural advantage rather than a marketing concept. The M18 platform today includes over 250 distinct tools: standard impact drivers and circular saws, pipe threaders for commercial plumbing work, concrete chainsaws for utility crews cutting through road surfaces, hydraulic knockout punches for electrical panel installation, heated jackets for outdoor crews working through winter. Everyone running off the same battery architecture, everyone covered by the same service system. One key, the Bluetooth-based tool tracking system built directly into Milwaukee's tools, gave contractors managing large crews across multiple active sites the ability to log every tool in the fleet, track its location, monitor usage data, and remotely disable a tool that had been stolen. The same capability that fleet management software provided for commercial vehicles applied to individual hand tools. Fuel, Milwaukee's brushless motor technology, removed the physical carbon brushes inside the electric motor that generated friction, heat, and wear over time. Brushless motors ran cooler, lasted longer, and delivered more consistent power output across the battery's discharge curve. The runtime and longevity gains translated directly into the two performance metrics professional tradespeople weighed most carefully before committing to a platform. On the professional job sites where Team Yellow had once held unchallenged ground, the balance shifted. Pro-grade users who had crossed over to DeWalt in the NiCad era were crossing back, not because of brand loyalty, but because of performance and results. Because of what the tools did. Platform loyalty followed performance. Team Red was not nostalgic anymore. It was the current argument on every job site and every forum where the trades talked about their tools. The company that had entered the 2000s, being described as an old man's tool, was setting the pace for an industry that had spent a decade leaving it behind. What connected every decision across that entire century was not any single technology. The technology changed constantly. Brushed motors gave way to brushless. Corded gave way to cordless. NiCad gave way to lithium-ion. What did not change was the engineering logic that produced the original hole shooter in 1918. Someone was doing physical work that was harder on their body than it needed to be. Find them. Watch the work. Build the thing that removed the cost. The fire in 1923 destroyed the building. Siebert rebuilt it by cataloging the failures of the competition. The Navy specification in the 1940s raised the production standard and never let it drop. The Sawzall in 1951 renamed its entire product category. The stagnation of the 1980s and 1990s nearly finished the company for good. The V28 lithium-ion platform in 2005 reversed the decline faster than anyone outside the building thought possible. The M18 ecosystem that followed built 250 tools deep on a single battery architecture. From a 5-pound drill requested by Henry Ford to a 250-tool cordless platform running on a single battery, the observation at the center of every product was the same. Someone was carrying weight they did not need to carry. Build the thing that sets it down. If you made it to the end of this one, this channel was made for you. Hit subscribe so you do not miss the next one. A like helps more people find stories like this. This has been Trades Archive.